We are happy to have you back on our channel. Today we are going to continue with Physics Advanced Level Paper 2, June 2001, question 2. In our previous video we answered question 1, so we'll go straight away to question 2. The question says, in figure 1, the meters labeled M1, M2 each reach 1.5 ampere when the switch K is closed. The source S supplies 300 watt to the resistor R1, R2 and 100 ohms. Calculate the potential difference across R1. That's Roman 1, and Roman 2, the value for the resistance or the resistor R2. So we are going to move forward to a proposed solution, and we have a circuit beside and we have a proposed solution. The first thing we'll do is to identify our values that have been given. We've been given the value of power 300 watts. Current, we've been told that the supply S gives a current of 1.5 ampere to M1 and 1.5 ampere to M2, meaning the total current leaving from S is 3.0 ampere. Now we look for the EMF of the source, or the potential difference across the source Vs here, which will be the 300 watts, the power of this source, divided by the current that flows from the source. So 300 watts divided by 3.0 have 100 volt. So Vs here is 100 volt. Now we need to take note that R1, look at this, R1, R2 and 100 ohm. This R1, R2, 100 ohm and this supply, they are all in parallel, meaning that the PD drop here is the same as the PD drop here, the same as the PD drop over R2, and the same as the PD drop over 100 ohm. In that case, we can say VR1 equal to VR2 equal to 100 ohm, which is equal to 100 volt that we just calculated above. Hence, in Roman 1, we were asked to calculate the value of the potential difference across R1. So we can say our R1 equals 100 volt. That's it for Romans 1. We'll move forward to Roman 2. Roman 2, we are supposed to look for the value of R2. The first thing, we will take note that the current that flows through M2 is 1.5 ampere. And the 1.5 ampere, when it comes at this junction, what happens? 0.5 ampere. There's part of the current that goes through R2 and part of the current goes through 100 ohm. Now we are supposed to get the current through 100 ohm by taking, in the previous slide we saw that the PD drop over 100 ohm was 100 volt. So if we take from Ohm's law that V equal to I times R, we can get the current through 100 ohm, and that current is 100 volt divided by the 100 ohm, which gives us 1.0 ampere. So 1.5 ampere reaches M2, 1.0 ampere goes through 100 ohm. So what happened? 0.5 ampere goes through R2. So if we know the current through R2, and we know that the potential difference drop there is also 100 volt, since they are all in parallel, what do? We can say that the current through R2 is equal to the potential difference divided by the resistance. You know that the current value is 0.5. So if you make R2 the subject of the formula, here what do we have? We have 100 divided by 0.5, which gives us 200 ohm. So the value of R2 is 200 ohm. Thank you so much for watching this video. Tell us how you feel in the comment section below. Just leave us a comment. And please, if you want to stay connected to our video, we invite you to subscribe. Just go below the video, you see the subscribe button. Click on the subscribe button and turn on the notification. Do not forget to also like this video. In our next video, we're going to be looking at question 3, June 2001. Please also remember to share the video with your friends and mates. Thank you. See you next time.